Hi math lovers, and welcome to this next video from the series 100 problems around the world. Today we have selected a problem from Australian Math Olympiad of 2006 from their final phase. But actually this problem, being a classical one, has appeared in many other Olympiads around the world, and that's why I think it is interesting to take a look at its solution. So the problem states that find all positive integers m and n such that 1 plus 5 times 2 in the power m is equal to n squared. As always, pause the video. Let's discuss some solutions in the comment section, because there are a lot of solutions to this problem and very elegant one, let's say, but I have tried to share a solution with you, which is, let me call it a brute force solution, but which has been very handy to me back in the years when I used to participate in the Math Olympiad contest, nationally and internationally. So, without further ado, let's take a look at what I thought as a possible solution for this problem. We rewrite the request that we're asked to find all these positive integers m and n such that they fulfill the conditions of this equation. So as I said, there are really many ways to solve this problem, but I will use the easiest one and the most intuitive one, brute force. And I will show you what I mean by that. It can be easily seen in this case that if we take the one from the left hand side to the right hand side, we will get that 5 times 2 to the power m is equal to n squared minus 1, or 5 times 2 to the power m is equal to n plus 1 times n minus 1. Now, since the left hand side is even, of course that also the right hand side must be even. So in order for this side to be even, n should be itself odd, which means that both n plus 1 and n minus 1 are even. Now, what does this mean? This means that there exists some k from the set of natural numbers such that 2 to the power m can be expressed as 2 to the power m minus k times 2 to the power k, because the sum of these two exponents is equal to m. Now, let's say in this equation over here, given that we have two factors in each of the sides of this equation, let's say that we can express it as 1 plus n plus 1 is equal to 5 times 2 to the power k, and n minus 1 is equal to 2 to the power m minus k. Now we try to manipulate and to do some, let's say, to do some calculations on this new system, and we will get that subtracting both sides of this equation, we will get that n plus 1 minus n minus 1 is equal to 2, and on the right hand side we will have that 5 times 2 to the power k minus 2 to the power m minus k is equal to 2. So dividing both sides by 2, we will get that 1 is equal to 5 times 2 to the power k minus 1 minus 2 to the power m minus k minus 1. So in order to solve this equation number 1 over here, we can factorize 2 to the power k minus 1, and we will get that 1 is equal to 2 to the power k minus 1 times 5 minus 2 to the power m minus 2k. So this is the equation number 2. In the equation number 2, the right hand side factors, given that both of them are natural numbers, they must both be equal to 1 in order to have parity between the left hand side and the right hand side. So we will get that 2 to the power k minus 1 is equal to 1, or 2 to the power 0, and 5 minus 2 to the power m minus 2k is equal to 1. Now we have the parity of exponents for the first equation of this system, and we will get that k minus 1 is equal to 0, and in the second equation we will have that 2 to the power m minus 2k is equal to 4. Or from the first equation we find that k is equal to 1, and the second equation becomes 2 to the power m minus 2 is equal to 2 to the power of 2. So k is equal to 1 and m minus 2 is equal to 2, which give us m equal to 4. Now, substituting into the initial equality given over here that m is equal to 4, we will get that n will be equal to 9, because the left-hand side value will be equal to 81, which indeed is the only solution of this equation, as we already found. Now, here we could have a hypothesis that n minus 1 could be equal to 5 times 2 to the power k, and n plus 1 could be equal to 2 to the power m minus k. But this system of equation does not have a solution. The viewer can easily verify that by following the same path, the same solution path that we saw together over here. So we finally say that the only solution to the given equation in the set of positive integers is m and n equal respectively to 4 and 9. So, if you like the solution, please support us by liking and subscribing. Thank you for your time and see you on our other videos. Up to then, goodbye.